Welcome to All This Math. This is Professor Parker, and today we're going to do some factoring by grouping. Factoring by grouping. So factoring by grouping is just how it sounds. You have to create groups, and typically we factor by grouping when we're given an even number of terms. So if you look at example 1, you see we have 1, 2, and of course terms are separated by plus or minus signs. Terms are separated by plus or minus signs because it could be argued that 12 is a term and 8 to the third is a term. So somebody could think, well, we actually have more than 4 terms in this expression. But in terms of how we deal with these problems, we think of terms as being separated by plus signs and minus signs. So therefore, that gives us 1, 2, 3, 4. 4 terms. So we factor by grouping when we have an even number of terms. The questions that you'll probably see, or the problems that you'll probably see, will have 4 terms. All right. You might see some with 6, but probably just 4, right? Now, when we factor by grouping, really all we're doing is pulling out a greatest common factor, aka a GCF. We pull out a GCF and then figure out what terms go inside the parentheses next to the GCF. That's really all we're doing, but we're doing it twice. We're doing it for each group, all right? Now, it's called factoring by grouping for a reason. We create groups. So if we got 4 terms, we're going to create 2 groups. And each group is going to have how many terms in it? 2, because 4 divided by 2 is 2. So when I start with number 1, I first want to create my groups. All right. So, and I'm gonna put my groups inside parentheses, right? So I'm gonna have 12a to the third minus 9a squared, and then that's plus 4a minus 3. I always like to put a plus sign when I factor by grouping, even if this was a negative, right? Like in this expression over here, number 2, this third term is a negative. I still like to set it up with a plus sign in between my 2 groups. All right, you don't have to do it like that, but that's how I like to get down, right? So then we got plus 4a minus 3, okay? So now, like I said, we have to know how to find the greatest common factor of each binomial. We have to know how to figure out what terms go inside the parentheses next to the greatest common factor. So if we look at this first group, I got a 12 and I got a negative 9. Out of those coefficients, the greatest common factor is a 3. It's a 3. 3 is the biggest number that can divide evenly into 12 and 9. All right. So I'm going to write my 3 down. Now, what about the variables? They both have a's. A's are in common. But when we're taking the greatest common factor, we always take the variable with the smaller exponent. So I got a to the third power and a to the second power. 2 is less than 3. So I'm going to use a to the second. So my GCF is 3a to the second. Then, like I said, we write parentheses next to the 3a squared. Then we got to figure out what goes inside the parentheses. So we have a GCF outside, and then we have 2 terms that are going to go inside. GCF outside and 2 terms that are going to go inside. How do I know it's going to be 2 terms, though? Because there were originally 2 terms. The way I find the terms that go inside the parentheses is I do division. I got to divide the original term by the GCF. Original term divided by GCF. Original term divided by GCF. So 12 divided by 3 gives me 4. A to the third divided by a squared gives me a. Because again, division rule of exponents. Division rule of exponents. We can't forget the exponent rules. The exponent rules pop up later, right? You might have learned them a minute ago, but the exponent rules pop up later, right? When you're doing division, you subtract the top exponent minus the bottom exponent. Top minus the bottom. So a to the third divided by a to the second gives me a to the first. So in the first slot in the parentheses, I put 4a, right? Then I do this. I do negative 9a squared divided by 3a squared. Then I'm going to do minus 3. And then what happens to the a squareds? Anytime you divide anything by itself or by the same thing, the quotient is always 1. The quotient is always 1. So that means that a squared divided by a squared, that's the same thing. A squared is a squared. A squared divided by a squared equals 1. So that means that will leave me with 3 times 1. 3 times 1 is 3, right? So that's all I got. So in here, that's what goes in the parentheses. So this binomial, this group, is factored. This group has been factored. Now we slide over here to the second group. We factor this. Look at the 4a and look at the 3. Well, negative 3 technically. The only greatest common factor between the 4 and the 3 is a 1. It's a 1. That's it. the 4 has an A with it, right? The 3 does not. So A is not common. The only thing these two terms have in common is 1. So that's my GCF. And 1 can be your GCF sometimes. And now we got to divide. Original term divided by GCF. Original term divided by GCF. So 4A divided by 1 is 4A. So I write that. -3 divided by the GCF is -3. So I write that. Now, the second group has been factored. Now, this is how you write this. Now, the next step is basically just to write the answer. Once you've taken the GCF of the first group and the second group, the mathematics is basically done. Now you just have to reorganize the problem, right? Now, here's another thing. The way that you know that you've been successful at factoring by grouping is if these two binomials match up, right? Because you're going to get two binomials. And they must be exactly the same. They must be exactly the same. The signs must be the same. The terms must be the same. They must be exactly the same. Now, if they're not exactly the same, that means you either made a mistake somewhere or you're just not able to factor by grouping. And that happens sometimes. Everything is not factorable. You can't break everything down using a factoring method. You just can't. All right. So here's what you do, though. You take this binomial that matches up or that repeats, and you write it down one time. So up here it's written twice, but in your final answer it's going to be written once, because technically speaking, what we're doing is we're taking the GCF again. So we're really saying that, okay, 4A minus 3 is actually a GCF of each of these two big terms, right? And then we do the same thing. We take the original term divided by the GCF. That will leave us with the terms on the outside. So then I'm going to have another set of parentheses, and I'm basically going to do this. This is the way I do it. Like, I just always thought, like, the binomial that repeats, I write it one time. The binomial that repeats, I write it one time. The two terms that are outside the binomials, I put them together. They become friends. They meet each other, and they become friends inside their own parentheses. So then I got 3A squared plus 1. And that is my final answer. Now, if I want to check my work to make sure, I see two binomials here. A lot of teachers teach FOIL method. Some teachers don't like the FOIL method. Really, I mean, it's just a way to memorize and make sure that you do the distributive property properly. That's all it is. That's all FOIL is. But anyway, multiply this out and make sure it equals the original expression. If it does, then that means you factor correctly. All right. And we can see that it does, because 4A times 3A squared is going to be 12A to the third. Then 4A times 1 is going to be 4A, which is right there. Then -3 times 3A squared is -9A squared, which is right there. And then -3 times 1 is -3, which is right there. So that means our answer is right. All right. And that's factoring by grouping, right? You look at your whole expression, you create your two groups, you factor out the GCF of each group, and then whatever binomial matches up, you write in your answer, you write that binomial one time, and then the terms that are outside the binomials or outside the parentheses, you put them together in their own parentheses. So your final answer should have two binomials. That's what your final answer should have. All right. Now, let's do this problem. All right. This problem is a little bit different, and you'll see why momentarily. So first step, I got 1, 2, 3, 4. Okay. Create your groups. Create your groups. So I got 35xy minus 5x. Now create my second group. Now I always put a plus sign in between. Like I said, even though this is -56y, I'm gonna always put a plus sign in between. So I got plus -56y plus 8. I'm gonna keep that negative sign with the 56. All right. Now I want to take out the GCF of this first binomial. The GCF. I look at this 35 and this 5. The greatest common factor of 35 and 5 is 5. 5 is the biggest number that can divide into 5 and also into 35. Okay? So my GCF, part of my GCF is going to be 5. Then I look at my variables, and I look at what variables are in common, right? Because it's a GCF, greatest common factor. So the x's are in common. The y is not, because only the 35xy has a y in it, right? So that means my x is in common. Now, in the other problem, we had to take the x with the smaller exponent. But in this problem, the x's have the same exponent. They're both x to the first. So we just take the x. Because in that case, technically, 1 is the smaller exponent. It's the only exponent. So 5x is my GCF. Then I got to figure out what goes inside the parentheses. What goes inside the parentheses? I figured that out by doing division. 35xy divided by 5x. 35 divided by 5 gives me 7. X divided by x. Again, we're multiplying something by itself. That gives me 1. Whenever you're multiplying something by itself, your quotient is 1. Or think of it as canceling out. So x divided by x is 1. The y is still there, though. The y is still there. We don't get rid of the y. The y is still there. That's part of the quotient, right? Then I do the same thing over here. Negative 5x divided by 5x. Negative 5x divided by 5x. It's always the original term divided by the GCF. Original term divided by the GCF. So that's going to give me minus 1. All right? So the first group is done. First group is done. Now, on to the second group. Over here, I got a negative 56 and a positive 8, right? Negative 56 and positive 8. I know that, because I know my multiplication facts, I know that 8 times 7 is 56. So therefore, the greatest common factor should be 8. So let me do this. Plus 8. And then put your parentheses. And then I'm going to divide the original terms by the GCF. So negative 56y divided by 8 is going to be negative 7. And then the y is part of the quotient. The y is part of the quotient. And then I'm going to do 8 divided by 8. Again, I'm dividing something by itself. I'm dividing something by itself. So my quotient will always be 1 whenever I divide something by itself. So now I got plus 1. Right? Now I got to check to see if my binomials match up. I got 7y minus 1 right here. I got, I got negative 7y plus 1 right here. Now you might be thinking, oh, but it's the same though. They both got 7y and 1. Nah, they not the same. Positive 7y is not the same thing as negative 7y. A positive is not the same thing as a negative. A positive is like having money. A negative is like owing somebody money. Those two are not the same thing, right? And then I got a negative 1 and a positive 1, right? They're not the same thing neither. But check this out, though. Notice how I pulled the positive 8 out for my GCF. It's a simple fix to this. It's a simple fix to this. I did this on purpose so I can show you what happens in that situation. It's a simple fix. When you take out a GCF, you could actually take out the positive GCF or the negative value. You can take out the positive or the negative, right? Instead of taking out the positive, let's see what will happen. I'm going to rewrite this part. And let's see. No, matter of fact, not even do that. Let's see what happens if I take out a negative 8 instead of a positive 8. Negative 8 instead of a positive 8. Let's see what happens. Put your parentheses. Negative 56y divided by negative 8 is positive 7y. Positive 8 divided by negative 8 is negative 1. Now my binomials match up. Now my binomials match up. So the moral of the story is, when you're factoring by grouping and your third term is negative, when it comes time for you to take your GCF out, you should pull out the negative GCF. That's a cheat code right there. That's a cheat code right there. That right there is worth the price of admission to this video, even though this video is free. But for real, yeah, that's a cheat code right there. When this third term is negative, pull out the negative GCF. See, we pulled out the positive GCF and bad things happened. We couldn't do our work. We couldn't finish it. But when you pull out the negative GCF, see how everything matches up? 7y minus 1 and 7y minus 1. You see that? You see? Yeah. So now, whatever matches up, our binomial, we write that. And again, it doesn't matter. Actually, I didn't say this before. It doesn't matter what order you write the binomials in, right? I could write the 7y minus 1 second, and I could write the 5x minus 8 first. It doesn't make a difference because multiplication is commutative. The same way we know that 3 times 2 equals 6, and we also know that 2 times 3 also equals 6. The order of the factors does not matter, right? So this is our final answer. And like I said, that cheat code right there, when you're factoring by grouping, if your third term is negative, when it comes time to take the GCF out of the second group, do yourself a favor. Do yourself a favor. Just pull out the negative GCF. Don't waste your time with the positive GCF. Pull out the negative GCF and see what happens. Everything should match up. Because if you pull out the positive GCF, and this was originally a negative term, this third term, because we got 1, 2, 3, 4, this third term, then you're going to have this situation. You're going to have this situation right here. And that's the situation that we don't want. We don't want this. Yeah, we don't want that. We don't want that. Because the binomials did not match up. That's why we didn't want that. Because we need the binomials to match up. In order to be successful with factoring by grouping, we need the binomials to match up. That's what we need to happen. We got to have the binomials match up. All right. Now, that's about it for that. I just wanted to throw you a couple examples of factoring by grouping that can help you in your studies. And thanks for tuning in. Like the video if you learned something. Share the video. Subscribe to the channel if you haven't already. And tell somebody to tell somebody else about it. Peace.